So today we're going to learn how do we write formulas and how do we name binary molecular compounds. Okay. So again, let's just start by breaking up those words. What does binary mean? Two. So these are going to be compounds that are just made up of two elements. And then just another vocab reminder, molecular are the same things as covalent. They're used interchangeably. You'll hear me use the word molecular compound and covalent compound interchangeably. Okay. So first, let's just refresh. How do we know if something is a molecular compound? Okay, so how you would be able to identify it is it's going to be two nonmetals. And then if you look at your periodic table, where do you find those nonmetals? Okay, so everyone pause really quick. Look at your periodic table. Where do you find the nonmetals? Where?
On the left side of the staircase.
Other side.
Right side.
Right side. Okay, so we have that bold staircase. They're the ones in that top right corner with one exception. What's the one exception? Hydrogen is also a nonmetal. Okay. So if you notice that there's two nonmetals, then you should be thinking molecular or covalent. Okay. And so these ones are the easy ones. They don't have charges. Okay, so no ionic charges, like no crisscross rule, no figuring out the charge to put in the name. Okay, they're very straightforward. The only tricky part with the nonmetals is the same two nonmetals can combine in more than one way. So, for example, we have carbon and oxygen. Okay, so here I have one carbon, one oxygen, so carbon monoxide. And here we have one carbon, two oxygens, carbon dioxide. Is there a very big difference between carbon monoxide and carbon dioxide? Okay, huge, right? One will kill you, one you have to have. So you can't just call it carbon oxide, right? You have to be able to distinguish those different compounds. So whenever we name these binary molecular compounds, we use prefixes just to state how many atoms there are in the compound. And so then here are prefixes at the bottom. Okay, so like prefixes, mono is 1, di is 2, tri is 3, tetra is 4, and so on. Go ahead and look at the back of your naming chart. Okay. At the bottom left, you see you have the prefixes. Okay, so do you have to memorize all of the prefixes? Okay, you do not. You just have to know what's on your naming chart, and you just have to know to use your naming chart. And then finally, the only other rule is kind of the same with ionics. The second element is always going to end in "ide." So, for example, oxygen would become oxide. Okay, like nitrogen would become nitride. Good. Okay. And then finally, just some extra rules when naming. So no double vowels of the same letter. Okay. So let's say we're just talking about one oxygen. It's monoxide rather than monooxide. Okay. Do you see what I mean here? So if it's like two double vowels the same, you just drop one of them. So monoxide rather than monooxide. And then the second extra rule, if the first element is a single atom, so quantity of 1, you aren't going to use the prefix mono. Okay. If it's any other quantity, then you will use the prefix. And we'll do some examples on the next slide to help you understand what this means. We're going to do 4 practice problems. So I give you the formulas. We're going to name them. Please do these 4 with me. Okay, so I want to see you writing down these 4. So our first one is CO. Okay. What's the name of C? Carbon. If there's no subscript here, what quantity is implied?
1.
Okay, so if the first element is 1, we don't give it a prefix. So C is just carbon. Okay. And then the second element is O. What is O?
Oxygen.
Okay, oxygen, but then we're going to drop the ending and add "ide." So what are we going to call it?
Oxide.
Oxide. And then for the second element, we always use the prefix no matter what. So again, if there's no subscript written right here, what number is implied?
1.
Okay, 1, and what's the prefix for 1?
Mono.
Mono. So we're just going to add mono and oxide together. So it's going to become monoxide. So CO is carbon monoxide. Next we have CO2. What's C?
Still carbon.
Still carbon. What's the quantity?
Still 1.
Okay, still 1. So if the first element is 1, does it get a prefix? Okay, no prefix. So it's just carbon. What's our second element here? Just the O. What's the name of O?
Oxide.
Okay, oxygen, and we're going to call it oxide, and this time how many are there? 2. What's the prefix for 2?
Di.
Di. Okay, so it's going to become dioxide. Okay, we have P4Cl3. What is P? Okay, phosphorus. This time, do you see how the quantity is greater than 1? Okay, so you have to add the prefix. So what's the prefix for 4? Tetra. Okay, and the first element name doesn't change. It's still phosphorus. There's no I there. So it'll become tetraphosphorus. And then it's Cl. So what is Cl? Chlorine, but how's it going to end? Chloride. And then what is 3? Tri. So it'll become trichloride. So we would say that one is tetraphosphorus trichloride. Can you try the fourth one on your own? So try N2O, and then we'll check answers. What do we call the N2? Okay, so it's dinitrogen.
Yeah, why does that sound so weird?
It's just it's unfamiliar maybe. And then what do you call the single O?
Oxide.
Monoxide.
Monoxide.
Okay, before we go on, let's look at a couple patterns. Okay, there's some patterns here. What do you notice how all of them end? What 3 letters do they all end with? Okay, so notice the second element, it's always going to end in "ide." What other pattern are you noticing about the second element? What does it get every single time? Okay, second element gets a prefix every single time no matter what, and it always ends in "ide." Then let's look at the first element. How does it end?
It always ends with the name of the first element.
Okay, so the first element naming, like the end, never changes. So no "ides" on the first one. Do y'all notice that? It's just whatever the element name is. Okay, and then sometimes they get a prefix. Other times they don't get a prefix. How do you know when you give it a prefix or not?
If it has more than one of it.
Okay, more than one. So if it's a single, like, quantity of 1, no prefix. Anything greater than 1, prefix. Okay, next we're just going to switch gears to formulas. So how would you write the formula if you had the name given to you? These ones should be very, like, simple and straightforward. All you're going to do is use the prefix, and that tells you what the subscript has to be. And then you'll just write the chemical symbol down. So in your notes, if you want, you could just write the example. So you could write down the tetraiodine non-oxide, and then we'll write the formula for this one. All right, so we have tetraiodine. What does tetra mean? 4. And then what element is in tetraiodine? Iodine. So what's the symbol for iodine? I. And so that tetra tells you it has a subscript of 4. And then we have non-oxide. The non is nana. So what number is nana?
9.
Okay, 9. And what element is oxide?
Oxygen.
Oxygen, which has a symbol of?
9.
Oh, so it'll become O9. Okay, so just I4O9. We're just going to do 2 more practice problems. So here we have sulfur trioxide. What is sulfur? The symbol. S. Okay. If there's no prefix, what subscript is implied? Okay, so just S. And then what should trioxide look like? Good. So sulfur trioxide is just SO3. And then last we have phosphorus pentafluoride.
Oh, sorry. She messed up the J.
All right, what's the symbol for phosphorus?
P.
P. And then what about pentafluoride?
F5.
Good. Okay, do you think you could do some of those on your own? Okay. All right, the last thing to talk about are just naming common acids. There's a whole slew of rules to learn how to name acids. And eventually we have to move on and learn other things. So we're not going to memorize all the naming rules for acids, but you do need to be familiar with the 6 most popular acids, both their names and formulas. Here is the good news. Most of them are on your naming chart. So take a look at your naming chart. And then they're on the very bottom right side. Okay. So just make sure they're on there. So these are the ones that pop up a lot. So we have hydrochloric acid, which is HCl. Okay. Sulfuric acid, H2SO4. Nitric acid is HNO3. Acetic is HC2H3O2. Phosphoric is H3PO4. And carbonic is missing on your naming chart, correct? I want you to add carbonic to your naming chart. So carbonic is H2CO3. Okay, so then if you're given the naming chart, do you have to memorize these? Okay. You don't. If it's the name acid, that one's obvious, so you know just to look for the acids on your chart. Let's say it's a formula. What do you notice about all of these formulas here?
They all start with H.
Okay, so if the formula starts with H, you should start be thinking like acid. Okay, so if it's H something, start thinking acid. And then can you look at the acid part of your page?